In this video we're going to have a look at three things: equations, tables and graphs. So I have an equation here which we have met before. Y equals negative 3x plus 2. From that equation I'm going to create a table. So a table of values. Here's my table here. And from my table I'm going to draw a graph. So these three things, equations, tables and graphs, are ways that we can display a particular relationship. So my equation has x and y in it. So y equals negative 3x plus 2. From creating my table, I'm going to have x and y in my table because in my equation I have x and y. And I've come up with some values for x. So you can just make up some values for x and then substitute into the equation each of those values for x in order to work out the corresponding y value. So when x is equal to 3, what is y? Okay, so when x is 3, y is equal to negative 3 times 3. That's what negative 3x means. So negative 3 times 3 and then add 2. So I get negative 9 plus 2. That's equal to negative 7. So from this substitution I can now come up with a coordinate which is just a point. So coordinates are written in brackets with a comma between the x and y value. And the first value in the brackets is the x value, which in this case is 3. And then we have the y value, which is negative 7. Now from that coordinate, I can plot it on my xy grid. And just notice that on an xy grid we have an x-axis, which is horizontal, and we have a y-axis, which is vertical. So 3, negative 7 will be, if I start at the origin, which is 0, 0, so the origin is right there, I'm going across to 3 on the x-axis and then down 7 vertically. So that coordinate there will be 3, negative 7. And just notice when you've got a negative number in the y value, that means you go down. If you come across a negative value in the x part of the coordinate, you go into the left. So let's have a look at the next point and just see if that is the case. So when x is equal to 2, substituting into the equation, we get negative 3 times 2 and then plus 2. So I get negative 3 times 2 is negative 6. Negative 6 plus 2 is negative 4. So my coordinate is 2, negative 4. Okay, so 2, negative 4, start at the origin, go across to 2 on the x-axis, and then down to negative 4 on the y-axis. So that point would end up here. Okay, let's try when x is equal to 1. So negative 3 times 1 and then plus 2 will give me negative 3 plus 2 will give me negative 1. So my coordinate is, the x value is 1, the y value is negative 1. So on my xy grid, starting at the origin, I'm going across 1 and then down 1. So I will end up here. When x is equal to 0, y is equal to negative 3 times 0 plus 2. That will give me 2. Negative 3 times 0 is 0. 0 plus 2 is 2. So that coordinate, the x value is 0 and the y value is 2. On my grid, go to the origin. My x value is 0, which means that there isn't any horizontal movement, so I just stay there on the x-axis at 0. My y value is 2, so I'm going up 2 spots there. And you can now start to see that on my grid if I were to join those points, you would actually get a straight line. Let's jump to when x is equal to negative 2. Y will be negative 3 times negative 2 and then plus 2. So negative 3 times negative 2 gives me 6. 6 plus 2 is 8. So when x is negative 2, starting at the origin again, go to the left 2 and then up to 8, which is up here. I'm going to join my points now. So would end up with, and of course you'd use a ruler, straight line through there. So that's a linear graph of the equation y equals negative 3x plus 2. Let's look at one more example. Y equals a half x minus 2. So our xy table again. First point, when x is equal to 3, y is equal to a half times 3 and then minus 2. That is equal to 1½ minus 2 will give me negative 1/2. So my coordinate is, the x value is 3, the y value is negative 1/2. So on my grid, going across to 3 and down half. So it should end up about here. Let's try the next one. When x is 2, y is equal to a half times 2 minus 2. So a half of 2, or half times 2 is 1. 1 minus 2 is negative 1. So my coordinate is 2, negative 1. So on my grid, I'm going across to 2 and down to negative 1, which will be there. So just filling in a few more values in the table. So filling in the table and then plotting the coordinates, you can see I'm getting a line which goes like this. If I were to draw a line through those points, end up with something like that. So mine's a little bit wonky. Of course you'd use a ruler and just make sure your line goes through all those points there. Now one other quick way that you could plot this type of equation is just use 2 points. So say I had a couple of points, x, say the 2 points were 4, and let's go negative 3. So what are the y values for those 2 points? So when x is negative 4, when x is 4, y is a half times 4 minus 2. So half times 4 is 2, 2 minus 2 is 0. So the coordinate would be 4, 0. And then if I did when x is equal to negative 3, then y is a half times negative 3. So a half times negative 3 is negative 1½ minus 2 will give me negative 3½ So negative 3½ So when x is negative 3, y is negative 3½ And if I were to plot those 2 points, 4, 0, 4, 0 would be here. Negative 3, negative 3½ would be here. And then with 2 points, as long as you've got 2 points, just join those 2 points together and then just check with one more point. So if I just say that this is a check point with x equal to 5, y is equal to a half times 5 minus 2. So a half times 5 is 2½. 2½ minus 2 will give me a half. So that point is 5½ Let's just check that it is on our graph. So if I go across 5 and up 1/2, yes, I do actually end up on the line. So with these types of relationships, you have an equation, you can create a table of values from the equation, and then come up with the coordinates, and then plot those coordinates whereby you can draw a linear graph.